All right, ladies and gentlemen, so you should have given Part B a try on your own before seeing this video. If we zoom in here, f of x was x cubed, g of x would be x cubed plus 4, and h of x would be x cubed minus 3. What I did is I first created the table for the x cubed function. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1, and I continued that pattern to get this parent table. Then I looked at x cubed plus 4. What is the thing that is different here? And the thing that is different is the plus 4, which means this is a vertical transformation, and it's moving the parent function up 4 units. So that meant for my rule, x is staying the same, but all my y values I'm going to add 4 to. So that meant all of these x's carried over to the new table, but all of these y's, I added 4 to them to get my new values. So negative 8 plus 4 was negative 4. Negative 1 plus 4 was 3, and so on and so forth. And then I graphed that, and I'll get to the graph here in a moment. Looking at the next one, x cubed minus 3. Thinking about what is different, it's this minus 3 that is different, which meant the whole graph, the parent graph, is getting moved down 3 units to make this function and to make this one's graph. So my x's stayed x, but all my y values transformed by subtracting 3. So negative 8 minus 3 is negative 11. Negative 1 from the original table minus 3 is negative 4. And that gave me these purple values. Looking at the pictures of the graphs, blue is the original, green is moving it up 4 units, and purple is moving it down 3 units. So that's wrapping up vertical shifts. So these are the 2 transformations you'll see for moving the functions up or down for a vertical shift. What we're looking at next are horizontal shifts. So some things you're going to want to highlight here. Horizontal shifts, let g of x equal f of x minus h. Then the graph of g is obtained by the graph of f by shifting right h units. Now we're going to be going through many horizontal transformations within this unit. And the phrase I use every single time with a horizontal transformation is x's always lie. X's always lie. Because a horizontal movement is moving it along the x-axis, all right, because that's the horizontal axis. So that means our x values will be affected here. And x is always lie because it's always opposite in reality of what you might think is happening, right? If I'm subtracting a number, we often think about that as, okay, the number is getting smaller. But the transformation that's really happening is it's going in a positive direction. It's going to the right h units. So x's always lie. It's always the opposite operation in terms of what it says. You might be also thinking, well, there's these parentheses and this f of x. This is all looking much different than it did with vertical. And that's because you're always dealing with a horizontal transformation when the change is happening inside of a grouping symbol. So we need to review what our grouping symbols are. So you might want to make a note of this at the top of the page here. Grouping symbols. Parentheses, very common grouping symbols. Anything inside parentheses is going to be affecting the graph horizontally. Another grouping symbol would be the square root symbol. Anything happening inside that square root symbol is going to affect the graph horizontally. And the last one that we're most commonly going to be seeing are the absolute value bars. Anything happening inside the absolute value bars is going to be affecting the graph horizontally. So taking a look at this example, f of x equals x squared and g of x equals f of x minus 2. So I know it says minus 2, but this new graph is actually created by shifting it 2 units forward. The other thing that you need to highlight on this page in terms of important notes is if we add h, and the fact that this is the letter h really doesn't matter. It's the fact that we're adding a number here inside a grouping symbol. That means we're going to go to the left h units. Another maybe catchy phrase that could be helpful, other than X's always lie, is add to X, go left. If that's a helpful little tidbit there for you to keep track of how adding a number is affecting the graph. You add, you go left. You subtract, you go right. So let's take a look at exercise 2, going through this together, and this will actually wrap up the 1.3 notes, so this will be our last example. Use a table to identify points, then sketch the graph of x cubed, f of x minus 4, and f of x and then minus 4 in the same coordinate plane. Again, in the instructions, it's using very mathy notation, so let's simplify this a little bit. The first one isn't so bad because f of x is x cubed. The second one, though, it says g of x equals f of x minus 4. What that really means for us is it's x minus 4 cubed. And if you're sitting there thinking, oh man, I don't know if I really understand that or if I would have been able to look at that and know that this is what it was supposed to look like. Well, I'm here to tell you and maybe to relieve some of that uncertainty, because whenever we give you problems in this class, we will not be using this more mathy notation, okay? We'll make it a little bit more simplified and just have it plugged in like this. So it's going to look like something you could type into a calculator and look at its graph or type into Desmos. So if you're feeling really uneasy about the way that this is written up here in the instructions line, notice that you really only see this type of notation in the notes because it's important to get exposure to it and to become a little bit more comfortable with it. But that's not the main idea here. I really want you to be comfortable when they're in this form. So this is what you would see on a homework assignment or a quiz or a test. All right, and then for h of x, it says f of x minus 4. Well, f of x, the parent function, is x cubed. So it would look like this. Now, I want us to note some differences here. This is a parent function. These two are not because they have additional numbers affecting the graph. Now, these cubes that are here are to identify for us what the parent function is. The fact that this is cubed on the outside is not really going to affect how we apply our rule, but is telling us that x cubed is the parent function. The x cubed here, again, is not necessarily going to be seen in our rule, but it is telling us that x cubed is the parent function. So let's fill in our parent table, just like we have on all the examples prior. And now let's begin thinking about g of x. Let's just focus there for now. X minus 4 cubed. Again, this cubed is just letting me know that the shape of this graph in the end is going to look like a cubic function because that's what its parent is. What is different about the way this is written in comparison to the parent function is not a power of 3 because they both have that. What's different are the parentheses in this minus 4. That minus 4 inside the parentheses is giving me information that this is affecting the graph horizontally. Now remember, x's always lie. I know minus 4 makes us think we're going to go backwards, but really, opposite, we are going to go forwards or to the right 4 units. So in thinking about our rule, it's horizontal, which means my x is going to change. My x is now going to get 4 added to it every time. And my y, there's nothing happening vertically, so my y is not going to change. So x plus 4 is here because that's the effect this minus 4 is going to have on the graph. It's going to push all of these original points forward 4 units. So all of these x's, I'm going to apply the rule to and add 4 to each of them. Negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. And then we get 5 and 6. Now my y values, according to the rule, y transforms into y, meaning the y value, the y coordinates from the parent table are not going to change. So I'm going to copy those in. Now I want you to take a moment before we move on to the last one to graph those. So graph the two parent function and then the one I have in green on the grid. And so you can begin to see that the original parent function in blue has been moved 4 units forward when we graph those points from the table we created. All right, let's wrap this up with just a quick recap of vertical, because now notice this one, my -4 of here in purple, is not inside a grouping symbol. It's not. There actually is no grouping symbol. There's no parentheses or anything here, which means this number of -4 is affecting the graph vertically. Vertical is always so nice to us, and as it reads is what it does. So this -4 means I'm going down 4 units. So my rule would be x comma y -4. All of my x's are going to stay the same, but all of my y values I'm going to subtract 4 from. And then I'm going to plot each of those points. Now -12 is kind of hard to graph because it is off, so it's okay if you don't get that one. Now you can see that the blue graph, if I moved all my points down 4 units, would give me the purple graph. All right, so that wraps up section 1.3, learning about vertical and horizontal shifts. You are now good to move on to the 1.3 homework assignment.